Recurrent neural networks. Description. Recurrent neural networks (RNNs) are a class of neural networks designed for sequential data, where each element in the sequence depends on previous elements. They are particularly effective for tasks involving time series, natural language processing, and other sequential data. Key components. Input layer. Description. Takes the sequential input data, where each element in the sequence is processed one at a time. Hidden layers. Description. Process the input data and maintain a hidden state that captures information from previous time. Steps. Features. Hidden state. Maintains a memory of previous inputs. Recurrent connections. Allow information to persist across time steps. Output layer. Description. Produces the output for each time step, which can be used for prediction or passed to the next time step. Working. Initialization. Description. Initialize the weights and biases of the network, as well as the initial hidden state. Forward propagation. Description. Process each element in the input sequence one at a time. Steps. Input at time t. The input at the current time step is processed. Hidden state update. The hidden state is updated using the current input and the previous hidden state. Output calculation. The output for the current time step is calculated using the updated hidden state. Loss calculation. Description. Compute the loss for the entire sequence by comparing the predicted outputs with the true labels. Backward propagation through time (BPTT). Description. Compute gradients of the loss with respect to the model's parameters by unrolling the network through time and applying backpropagation. Parameter update. Description. Update the model's parameters using an optimization algorithm like SGD or ADAM. Types of RNNs. Vanilla RNN. Description. Basic RNN with a single hidden state and simple recurrent connections. LSTM long short-term memory. Description. RNN variant designed to capture long-term dependencies and mitigate the vanishing gradient problem. Key components. Cell state. Maintains long-term memory. Gates. Control the flow of information. Input gate. Forget gate. Output gate. GRU-gated recurrent unit. Description. Simplified LSTM variant with fewer parameters and similar performance. Key components. Update gate. Combines input and forget gates. Reset gate. Controls the influence of previous hidden states. Applications. Language modeling. Description. Predict the next word or character in a sequence. Used in text generation and autocompletion. Machine translation. Description. Translate sentences from one language to another. Speech recognition. Description. Converts spoken language into written text. Time series forecasting. Description. Predict future values in a time series based on past observations. Sentiment analysis. Description. Analyze the sentiment of text data, such as determining the polarity of a review. Advantages. Sequential data handling. Description. Naturally suited for processing sequences and time-dependent data. Temporal dependencies. Description. Capture and utilize dependencies across different time steps. Challenges. Vanishing exploding gradients. Description. Gradients can become very small or very large during training, hindering learning. Long-term dependencies. Description. Difficulty in capturing dependencies that span many time steps. Computational complexity. Description. High computational cost due to sequential processing of data. Recent advances. Bidirectional RNNs. Description. Process the input sequence in both forward and backward directions to capture past and future. Context. Attention mechanisms. Description. Allow the model to focus on relevant parts of the input sequence, improving performance on tasks like translation and summarization. Transformer models. Description. Use self-attention mechanisms to capture dependencies without relying on sequential processing, offering superior performance on many NLP tasks.